Turn to page 144. First of all, example 4, we're going to skip. It's a big, nasty word problem. You can read over it if you would like, but we're going to skip example 4. Turn to page 144, and in the column at the top, you can write down example 5, and we're going to make up our own example of where there are two square roots. Square root of x plus 3 equals the square root of x minus 5 plus 2. So once again, this one has two square roots. One of them is isolated. Can you see that the square root of x plus 3 is isolated all by itself on one side? The other square root is not isolated. But in step 1, where I say isolate a square root, you just need to isolate one of them. And then you can go to step 2, where if you want to get rid of that square root, you square both sides. So since the square root of x plus 3 is all by itself, we can square both sides. But now when we square this side, we've got a big thing that gets squared. And this is nice because when you square the left side, that goes away and just becomes x plus 3. But when you square the right side, you have to think of this as the square root of x minus 5 plus 2 times by the square root of x minus 5 plus 2. So you're going to have to FOIL and multiply it out. Now when we multiply this times this, we're going to just get x minus 5. Can you see that the square root of x minus 5 times the square root of x minus 5 will just be x minus 5. When you multiply this times this, you're going to get plus 2 square root of x minus 5. And these ones, another plus 2 square root of x minus 5. And finally, 2 times 2 will be plus 4. Combine all our like terms. So I'm going to have x plus 3 equals x minus 5 plus, can you see that these two are like radicals? You could put them together and get 4x minus 5 plus 4. And we still have one square root. But it's better than what we began with because we began the question with two square roots. So when we look at our instructions, this is the first time that we're going to have to use step 3, where we have to repeat, because we still have a square root. So we're going to have to go back to step 1, isolate that square root, and then square again. So there's my 4 root x minus 5. I'm going to subtract x on both sides. I'm going to add 5 to both sides. And I'm going to subtract 4 on both sides. That way, on my right side, I'm just left with 4 root x minus 5. On my right side, x minus x will go away. 3 plus 5 is 8, minus 4 is 4. This plus 4, because this one and this one are like radicals. So I have 2 plus 2 will get 4 of them. Now I can divide both sides by 4. And I'll get 1 is equal to the square root of x minus 5. Square both sides. 1 squared is 1. So I'll square this side, square this side. 1 equals x minus 5. Add 5 to both sides. And we get x equals 6. We're going to verify it just using some mental math. Okay, let's go back to our original equation. Our original equation, well, I'll write it out again here. Original equation had the left side as root x, plus 3. The right side was root x minus 5 plus 2. If you plug in 6 for x, can you see on this side you're going to get root 6 plus 3 is 9. Square root of 9 is 3. On this side, 6 minus 5 is 1. Square root of 1 is 1. 1 plus 2 is 3. And we know that this answer works. So this is an example of one with two square roots where you isolate and square, but you only get rid of one of them. So then you have to repeat the process and isolate and square again.
Would there be a question on like the pre-quiz that wouldn't be able to be solved?
The one on the pre-quiz that won't be able to solve will be similar to example 3 that we did, where it was a square root equals a square root. Okay? Later on, once we learn quadratic equations, we come back to these and then it becomes a quadratic equation we have to solve. And then it has a better chance of having more extraneous roots. But for now, these are the ones. There are no questions like this one in your book. If you would like one to practice, I'll make one up for you right now. So, square root of there. I believe that works. Yes. That does have a nice answer that works.